Flight engineers at the University of Central Florida are figuring out the secret to safe hypersonic travel.
The United States is on the verge of exposing its fastest hypersonic jet, one that's said to come close to the speed of light. This incredible machine is a huge leap forward in aviation, promising speeds that could change everything we know about travel. Built by the innovative Hermeus team, the jet known as Quarter Horse is not just a dream, but almost ready to take to the skies. Could this be the start of a future where travels that took hours are reduced to mere minutes? We are going to explore how this groundbreaking jet will reshape the skies forever, breaking speed limits in the air. In the fast-paced world of aviation, breaking speed barriers is always a hot topic. Rockets and spacecraft from the US have reached what's known as hypersonic speeds. That's really fast, faster than most of us can imagine. Despite this, the idea of using such speeds for regular airline flights through the air has yet to become a reality. Many of us might daydream about zooming at such incredible speeds in a plane full of passengers. Do you remember the Concorde? This famous plane was a big deal in supersonic travel, which is super fast but still not as fast as hypersonic. The Concorde once hit a top speed of 1,354 miles per hour. Now that sounds quick, but hypersonic speeds begin at Mach 5, or roughly 3,836 miles per hour, so there's still a way to go. Before we dive deeper, it's clear that what's holding back hypersonic travel is far more startling than anyone could have guessed. And this won't be the only detail that will leave you amazed. Let's go back in time a bit, over 20 years. In November 2003, the Concorde took off for its last flight. On this final trip, the famous G-Boeg plane set a record for the fastest flight across the country from New York to Seattle. It completed the flight in just 3 hours, 55 minutes, and 12 seconds. But there were rules about flying that fast over land in the US, so the path had to be changed. Canada allowed the plane to fly super fast over areas where not many people lived. This last flight felt like the end of an important chapter. It seemed like we might be closing the door on future leaps forward in super fast travel. But you know what they say about nature hating empty spaces. That's where Hermeus comes into the picture, aiming not just to replace the Concorde, but to totally outdo it. Hermeus is a new company with big dreams. They want to make a passenger aircraft that doesn't just match the Concorde, but goes way beyond it. Imagine flying from New York to London in just 90 minutes. The Concorde used to take almost 3 hours for this route. For A.J. Piplica, the boss of Hermeus, that's just not good enough anymore. He has pulled together a team of smart folks from SpaceX and Blue Origin. These are people who love pushing the limits and want to change the way we think about flying. They're working together to start a new chapter in the world of fast travel. Their big project is called the Quarter Horse. It's an unmanned prototype that aims to break the speed record set by the Lockheed SR-71 Blackbird. This old spy plane is still one of the fastest planes around. But beating such a record isn't easy. It needs amazing engineering skills and a lot of power. The SR-71 used a special engine called the Pratt & Whitney J58, which could push it to speeds over Mach 3. But the folks at Hermeus think they can do even better. They've decided not to just use old tech. They're building their own engine from scratch, called the Chimera. The Chimera isn't just any engine. It's a masterpiece of engineering. It gets its name from a mythical creature that could breathe fire and was part lion, goat, and snake. This engine brings together elements from different types of engines to create something completely new. It's called a turbine-based combined cycle, TBCC, engine. This means it combines the best parts of gas turbines, turbojets, and ramjet or scramjet engines. What's really cool about the Chimera is how flexible it is with speeds. Regular turbojet engines are great at speeding up from a stop and can go a bit faster than Mach 2. But they can't keep up hypersonic speeds, which are Mach 5 or more. On the flip side, ramjets and scramjets are fantastic at those super high speeds, but can't handle going slower. Hermeus has figured out a way to blend these technologies so their engine can handle both slow and super fast speeds with ease, making it perfect for a range of flying conditions. This blending of tech helps make the Chimera incredibly efficient and stable, no matter the speed. It's a big leap forward in making super-fast travel possible for more people. Imagine a future where flying across the Atlantic could take less than the time it takes to watch a soccer match. That's the future Hermes is working towards. Just when it seemed like the age of super-fast flights was ending, a new company stepped in, ready to go even faster and change everything. Hypersonic planes could change the world. And it's not just about speed. Flying faster could change a lot of things. It could make the world feel even smaller, bringing distant places closer together. It could shake up the airline industry by setting new standards for speed and efficiency. There's a lot of excitement around what Hermes is doing because it's about more than just going fast. It's about opening up new possibilities. As we look ahead, the work of Hermes could inspire more innovations in the aviation industry. Maybe other companies will see what's possible and start to develop their own super-fast planes. The race to hypersonic speeds could push technology to new heights, leading to even more advancements in how we travel through the air. It's a thrilling time to watch as new chapters in aviation history are written, driven by the dream of making the whole world more accessible at speeds we once thought were left to the realm of science fiction. In November 2022, the team at Hermes made big news in the aviation world. They successfully tested the Chimera engine, making it switch from turbojet to ramjet mode smoothly. This was a major step forward for the company, which is pretty new to the industry. This kind of engine can lead to building planes that fly incredibly fast, changing how we think about flying altogether. What's clever about Hermes's approach is that they didn't start from scratch. They used engines that were already out there, which are usually made for less speedy aircraft. By doing this, they saved a ton of money, billions of dollars, and also saved a lot of time. This shows that being innovative doesn't always mean you have to start from the very beginning with something completely new. As 2024 started, Hermes had just finished a round of important tests on a model they call the quarter-horse Mk0. This isn't a plane that flies. Rather, it stays on the ground and lets engineers check out different parts and how well they work together. This testing happened in Tennessee at a place called the Arnold Engineering Development Complex. Here, the team looked at how the model handled commands from afar, how it dealt with signals, and how it moved on the ground. These tests weren't just about ticking off boxes on a checklist. They were crucial in moving towards the goal of making super-fast flight something anyone can experience. March 2024 saw Hermes building on their success by introducing another model, the quarter-horse Mk1. This one is designed to actually fly and is set to do so by the end of the year. It's going to take off from Edwards Air Force Base, which is a place known for being at the forefront of aviation. The Mk0 was all about ground tests, but the Mk1 is stepping things up. It's built to handle very fast takeoffs and landings, important features if hypersonic planes are going to be a regular thing. The Mk1 is expected to really push forward the speed at which aviation technology develops. Looking ahead, one of the most exciting things at Hermes is the work on the quarter-horse Mk2. This version will have an even better engine called the Chimera 2. This new engine will use parts from the Pratt & Whitney F100, a reliable engine you'd find in powerful fighter jets like the F-15 Eagle and F-16 Fighting Falcon. In May 2024, the team began testing a new cooling system with the F100 engine. This is another big milestone for the Mk2. By combining this strong engine with innovative cooling tech, the Mk2 could reach speeds up to Mach 2.5. That's seriously fast. So fast it could break the sound barrier and show that planes can fly autonomously at speeds below Mach 3. But the real test for Hermes is still to come with the quarter-horse Mk3. This plane aims to do something truly amazing, switch from turbojet to ramjet while flying. If they can pull this off, it might even break the speed record set by the legendary SR-71 Blackbird. The Mk3 is looking to hit speeds up to Mach 4, pushing the limits of what's possible in flying fast. While there's no set date for when this might happen, the team's rapid progress gives everyone a lot of hope. As Hermes works on making their fast planes a reality, They have even bigger plans that could completely change the way we travel in the future. Hermeus's big plans for superspeed. Hermeus is setting its sights high, aiming to revolutionize the way we think about air travel with not just one, but a whole series of hypersonic aircraft. They're not limiting their ambitions to just regular planes. They're expanding their focus to include a whole variety of super-fast vehicles. First up, they have the quarter horse, which is just the beginning of their innovative endeavors. They're also planning to develop a versatile hypersonic UAV, unmanned aerial vehicle, geared towards defense and security tasks. This UAV is designed to be adaptable and efficient, meeting the high demands of modern security measures. Then there's the Halcyon, a passenger aircraft that's in a league of its own. This plane is designed to traverse over 125 transoceanic routes, zipping through the skies at speeds 5 times faster than today's fastest commercial jets. Imagine boarding in New York and stepping off in London just 90 minutes later. What sounds like fantasy could soon become reality thanks to Hermeus. Their vision extends beyond just cutting travel times. They're looking to fundamentally change how we connect across the globe. Backing Hermeus in these ambitious projects are some of the biggest names in technology and aerospace. NASA, the US Air Force, and Sam Altman, the tech guru behind OpenAI and ChatGPT, have all thrown their substantial support behind the company. With their help, Hermeus has secured hundreds of millions of dollars in funding. This isn't just money. It's a huge vote of confidence in Hermeus's potential to alter the future of flight. The financial and institutional support underscores a widespread belief in the viability and necessity of Hermeus's work. The excitement around what Hermeus is doing isn't about whether they will succeed, but about how quickly they can bring their high-speed dreams to life. Looking at the bigger picture, Hermeus's efforts are about pushing boundaries and setting new standards. They're not just trying to improve on what already exists, they aim to create something entirely new, a way of flying that could change the world. The implications of their success would be profound, making what once seemed impossible, like hypersonic public travel, a tangible, everyday possibility. It's a challenge, sure, but one that Hermeus is well prepared to tackle. But let's talk more about what these developments could mean for all of us. For starters, the world would feel much smaller. A quick trip across the ocean could be done in less time than it takes to watch a football game. Business meetings could be held on different continents on the same day. Families and friends spread across the globe could connect more frequently and easily. The ripple effects on international business, diplomacy, and tourism would be enormous, not to mention the environmental impacts if these aircraft can be made more efficient than fleets currently in the air. Then there are the technological advances that could come from this. The challenges of designing aircraft that can safely travel at such high speeds push the limits of material science, engineering, and aerodynamics. Every problem solved on the way to achieving hypersonic flight could spin off a dozen new innovations. Maybe new materials that are lighter and stronger than we have now, or advances in fuel efficiency that could benefit all forms of transport. Moreover, consider the implications for the planet. If we can travel faster, maybe we can also find ways to make travel cleaner. Hermeus's focus on advanced technology could lead to breakthroughs in sustainable aviation fuels, or even entirely new methods of propulsion that reduce aviation's carbon footprint. Imagine hypersonic planes that aren't just fast, but are also leading the way in eco-friendly travel. It's also worth thinking about the economic impact. New industries would emerge to support this high-speed way of life. There'd be new jobs in everything from the construction of these planes to the infrastructure needed to support them, from high-tech control towers to new types of airports. Entire regions could be transformed by the presence of a hypersonic hub, bringing more jobs and boosting local economies. To truly understand today's world of flying, we need to look back at the important moments and big leaps that got us to this point. How airplanes took over the world. The story of how flying developed in the United States is filled with amazing advances, starting in the early 20th century with the Wright brothers. On December 17, 1903, they managed to fly at Kitty Hawk, North Carolina. This historic flight, which lasted 12 seconds and went about 120 feet, was the first time a machine heavier than air flew with power, stayed up, and was controlled. This moment laid the groundwork for the swift changes in flying tech that came after. In the beginning years, aviation reached several important points. During World War I, people started to see practical uses for flying beyond just testing things out. After the war, daring pilots used leftover planes for different jobs like taking photos from the air, helping the police, and even farming tasks, such as spreading pesticides on crops. By the late 1920s, newer planes with closed cabins marked a move from the open cockpits of the past to more modern, passenger-friendly flying. As people wanted planes that were faster, safer, and worked better, the development of jet engines became a key change in the history of flying. By 1950, jet engines were so powerful compared to older piston engines. The creation of jet engines meant planes had to change to fit more passengers, go faster, and handle the pressure of flying high. For example, the Boeing 777 with its GE 9115 engine shows how far these advances have gone, giving more power and making jet planes last longer. Commercial flying grew a lot after World War II. The start of the Federal Aviation Agency, FAA, in 1958, after a bad crash over the Grand Canyon, showed the government's serious promise to keep flying safe and under control. Later called the Federal Aviation Administration and made part of the Department of Transportation in 1967, the FAA worked hard to keep the skies safe, dealing with more planes flying and the need for better systems to control air traffic. There are many big moments in this history. In 1919, John Alcock and Arthur Whitten Brown flew non-stop across the Atlantic from Newfoundland to Ireland in 16 hours. In 1927, Charles Lindbergh's solo non-stop trip across the Atlantic showed the world the big possibilities of flying for global travel. By 1939, jet power moved ahead with Germany's Heinkel 178, beginning the age of jets. Just after that, in 1947, Chuck Yeager flew the Bell X-1 and became the first person to break the sound barrier while flying straight. The jet age changed both commercial and military flying a lot. The start of commercial jet flights in the 1950s with the British de Havilland Comet meant planes could fly faster and further than ever before. U.S. companies like Boeing quickly caught up, making jet planes that turned into the main part of today's commercial flying. Military flying also saw big improvements during this time. Jet-powered bombers like the Boeing B-50 played important roles, even though newer planes soon took their place. The creation of faster-than-sound jets and better systems for navigating and watching areas showed a constant push for better tech. Flying has also helped a lot in exploring science and space. The launch of the Soviet Union's Sputnik in 1957 started the space age, making the U.S. push harder in space exploration. By 1969, the Apollo 11 mission had people walking on the moon, using all the lessons learned from many years of aviation research. The history of aviation in the U.S. shows a path of tech progress, bold first steps, and a continuous aim for better speed, efficiency, and safety. From the first days of flying tests to setting up groups like the FAA, flying has grown into a key part of how we travel and explore today. Is this hypersonic jet truly capable of reaching light speed? Or is there more to the story than we're being told? Share your thoughts, and remember to like and subscribe for more.